Okay, so we understand the logic behind the z-score table a little bit. Let's use it in our advantage. So it's an incredible tool that we can use to find out areas on the normal distribution or number of standard deviations and kind of do a bunch of cool stuff. So let's say that I have a distribution here, sample, right, where the mean is 0, okay? And I want to know what percentage is more than 2.5 standard deviations of the mean. Okay, so I want to say that, you know, if everything goes less than 2.5, it's good. More than 2.5, it's bad. What is that area is going to be? How do I find that out? How do I find this area? So what we're really asking here, right, what is that area is all about, we start by looking what that area is not, right? That's kind of all the rest of the area, right? Because we know that everything is 1, right? Everything is 100%. Now we need to find this area by finding the area in this left side, okay? We can use it, you can calculate using the table, or you can use Excel to do it. So how can we do with the table? Well, the table, z-score table, is here. As you can see here, it tells you the area on the left. So if you want to find the area here, we're going to have to calculate the area in this side of 2.5 standard deviations, and then take 1 minus this, because 1 minus this equals to this, which is what we want to find out, right? Only that, you know, smaller piece in the right. So the table is giving you this. So you need a z of 2.5. How we're going to find that out? Z's are here and here, right? So we're going to look at here the z-score. Oops. You can see here is start with 0. And 0 is 50%, right? So if you're going to look and say, okay, how much do we have on the left on the negative value, right? How much you have here to the left? Well, we have 50%, right? Because the mean is the middle point. So z-score of 0 is 50% because you are here, right? And then z-score of 2.5, so it is 99.38. You can see here, right? So 2.5 plus 0. Right? If you want a 2.55, you have to look at 2.5 and then find this side here, which will be exactly here. But we only 2.5, so it is 99.38. Okay, oops, we got it back. So then what we need to do is just take 1, so you can see 2.5 and 0. So it's 0.9938, that's this area. And 1 minus this is going to give me this area. So 0.062, right? Or 0.62%. Okay? So and then the other way to do that is just to put in Excel the function norms dist, and you put the z-score here, the 2.5. So equal norms dist 2.5. Okay? And here what we're doing in Excel equals norms dist 2.5, and you give me the same value. 1 minus this is the same 0.00621. Okay, so we need to do 1 minus that, and that's kind of the logic of that. Okay. Okay, but in that case, we already had the 2.5 and say, okay, it's 2.5 standard deviations of the mean, right? And how do we get this 2.5, right? In a real case example, you're not going to have the 2.5, you're going to have a measurement, right? So more than 50, more than 35, more than 12.5, right? So how do you get that 2.5 standard deviations? And this is the formula. Okay, I know it looks fuzzy, it looks weird, but it's not. Let's take a look at one example. Okay, let's say that we gather lots of data on the fill volume of 10 milliliter syringes. So we're in the pharmaceutical industry. That's actually an example from Nephron Pharmaceuticals. So we have 10 milliliter syringes, and we do some descriptive statistics of how many mLs we're putting. and the mean is actually 10.2 with a standard deviation of 10.01. Now let's take one volume of 10.22 and see, what will be the probability of putting more than 10.22 milliliters, right? Or what is the distance between 10.22 to 10.2 in number of standard deviations, okay? So, very, again, simple math. I'm just going to take that 10.22, okay, which is my x value, minus the mean, which is the 10.2, right? So that's a difference in mLs, right? So there is a 0.2 mLs difference. And then what I'm going to do here is I'm going to divide it by the standard deviation. So it's 0.02 divided by the number of standard deviations, 0.1. So it's 0.2 mLs, and I divide it by what is one standard deviation, which is a 0.1 ml, and the answer is 2. So it means that the value of 10.22 is 2 standard deviations to the right of the value of 10.2. And then that's when I get the number of standard deviations. Now I know how many standard deviations I have from the mean, and then I can find the value, the probability of filling a syringe more than 10.2 mLs by the math and the calculation that we did before. Okay?